Okay, welcome back. Today is going to be a review day. So we're going to do a couple of problems together, and then there's going to be a little click-through assignment for you to complete, labeled 7.4, in order for you to get the credit and the points for this. All right, we're going to do kind of one of each type of problem for you to work your way through and to test yourself. So pause it at any point. I'm just going to keep working through it. You can just pause, try it, and then check your answer. You can kind of fast forward as you go. Okay, practice problems. Number one, the Carousel Valley Fair has a radius, that's R, of 3.42 meters. It takes 4.1 seconds to circle once. That would be your period. The capital T is 4.1 seconds. What is the centripetal force if your mass is 95 kilograms? That's your M. And how many G's will you feel? All right, so looking through it, centripetal force, my easiest equation for centripetal force is the Fc equals m times v squared over r. Get rid of that. I have my mass, I have my r, I do not have my v. I am moving in a circle at constant speed, so I can first use my equation to solve for velocity. V equals 2 pi r over t. And once I have my velocity, I can plug it in to solve for the centripetal force. And then finally, I'll be able to find the number of g's. I've got that equation up here. Once you know the total force, the centripetal force, the force will go on top, and you'll divide it by mass times 9.8. It is an absolute value, so you can just get rid of any negative signs. All right, starting from here, with my velocity, I need to find 2 times pi times r, 3.42, and I need to divide it by the 4.1. Take a moment, do your math. You should get a velocity of 5.24. Once I have my velocity, I am ready to move on to equation number 2. I need to find the centripetal force. Fc is equal to mass, 95, times my velocity, squared, don't forget to square just your velocity, divided by your radius, which is 3.42. When you multiply all of that, divide by the 3.42, you get a centripetal force of about 763. In class, I will go slower and make you work through it, so just make sure to hit pause whenever you need it. All right, from there, my last step, I need my G's. I gotta take the total force that I just calculated, is 763. I divide that by my mass, which is 95, multiplied by the negative 9.8, but it is an absolute value, so all the negative signs are gonna just disappear. If I take that, I find my G's to be a little less than 1. I got 0.82. All right, so filling things in, I found my velocity to be 5.24 meters per second. I found my centripetal force to be 763 newtons. And once I found my G's, it was less than 1. I feel lighter, so it would be 0.82 G's. Moving into, apparently I did number these well. This should be 2. What is the acceleration due to gravity at a point 4,000 meters above the Earth's surface? Okay, I want to find gravity. The only equation I have to do gravity at any location is our gravity equals G times M times R squared. Okay, my G, that is saved in my calculator. That's your 6.67 times 10 to the negative 11. The M, it is saved in your calculator. It is the mass of the Earth, that's what I'm working with, so that's the 5.98 times 10 to the 24th kilograms. The R, I have the radius of the Earth saved in my calculator, the 6.37 times 10 to the 6, but to that, I need to add how much higher we are, which is 400,000 meters above the surface. So I need to add the 400,000 meters to the actual radius of the Earth to get the total distance from the center to the surface is the Earth's radius. You have it stored as r, and then to that I have another 400,000 meters. When I add those together, I get 677,000 meters. Okay, I now have all of my numbers. Once again, you can write them all in when you're going to solve for it, or you can use G and M because that's how you have them saved in your calculator. So I need to take G, 6.67 times 10 to the negative 11. I need to multiply it by the mass of the Earth, 5.98 times 10 to the 24th, and I need to divide that by the radius that I am currently working with, the 6770000, but I have to remember to square the radius at the bottom. Into your calculator, if you don't have them saved, then you'll need to type them in using parentheses. If you have them saved, you just hit alpha G times alpha M, hit enter, and then divide it by that number squared. A reminder, it will always, always, always be a normal number. It won't have a bunch of exponents in. When you do this, you should get 8.7 meters per second squared. That is the gravity at the location 400,000 meters above the surface of the Earth. From there, what velocity must a satellite maintain to stay in orbit at this distance from part A? All right, so part A, I just found my gravity already to be 8.7. I don't need to recalculate that. I already have it. I'm ready to go. I also found that my R was 6770000. I don't need to recalculate that. It's the same R as the previous problem. I want to find the velocity. The only equation we have for velocity of an orbiting object, so we have to use the one in our current unit, is G equals V squared over R. All right, so G, 8.7 equals V squared over our R, 6770000. From this, reminder, this multiplies over, but then that's not V, it's V squared, so you will have to square root as well. So if I take 8.7 and multiply it by my radius here, I get a really big number. That's not V, that's V squared. I got 588999000. That is not my velocity, that is my velocity squared. So my last step, I am going to square root that number, and I get 7675 meters per second. All right, that's just a quick review of what you can expect to see on your quiz tomorrow. So please let me know via text or in class if you have any questions. Thank you.